All right, physics fans, so you want to know something about friction? Well, let's talk about it. So, to help us out, I have my friend Jason Todd, aka the Red Hood. Yes, Batman and all of his friends are awesome. Although I find myself loving Jason Todd because he's really dark. I don't know. I'm saying that. She's got issues, I guess. All right, so let's try and analyze this. So first, to analyze anything, we draw a force diagram. And to do that, we have to pick our system. So I'm going to choose him and the motorcycle, and we're going to try and figure out what is the force of friction on this motorcycle. All right, so that's our goal. So if I'm picking him and the motorcycle as my system, then I need to draw a force diagram. So I also need to know a few facts. So let's see, Red Hood and motorcycle. All right, so that's my system. So now if I draw a force diagram, then I've got the force of gravity pulling us down on the cycle and Hood by Earth. And then it's going to be supported by a normal force pushing up, force normal on the cycle and Hood by the ground. And then finally, since he's moving in this direction, friction always opposes the intended motion. So since the motorcycle is going that way, friction is going to work against that. So I'm going to have the force of friction acting in this direction on cycle and Hood by ground. Now, since he's slowing down, this could be unbalanced, but he is not accelerating in the y-plane, so those are balanced. So there's my force diagram. All right, so now we're going to actually try and do some mathematical calculations. So I'm going to actually replace the Red Hood here. I'm just going to do a little swap. I'm going to actually replace this with just the mass of everything. So I did some checking, did my nerd work, and I found that the mass of the Red Hood is about 90 kilograms. And then the mass of the cycle is about 200 kilograms. And so what this means is that my entire system has a mass of 290 kilograms. So I like to put the mass of my system inside. But I thought we should first, analyze it, break it down. So now when I go to do this math, I'm going to do my net force equations in each plane. The reason why I'm doing them each plane is because this normal force is going to have an effect on this force of friction because they are linked, since they are both on the Hood by the ground. All right, so they have the same on by notation. So the normal force here is connected to the force of friction. Sometimes you might have multiple normal forces, and in order to figure out which one's connected to the force of friction, that's why you have to use that on by notation. This is a very simple example, so I don't have to worry about anything too complicated. So first I'm going to try and solve for that normal force. So sum the forces in the y-plane, set them equal to 0 because all my forces are balanced. Then I have the normal force pointing up minus the force of gravity pointing down, and then I'm going to do some replacement. So normal force, replace the force of gravity with the equation for the force of gravity, that's mg. And so then I get Fn minus my mass of my system, which is 290 times 9.8, because that's the gravitational field strength of the Earth. We're going to assume that Gotham City is on Earth. And so then when I do that math, I get an answer of 2,842 newtons. So that's my normal force. Now, to solve for the force of friction, I need to put this over here. Let's go back to red. Come on, it's Red Hood. You need red. So I just care about the force of friction. So the force of friction is equal to mu times the force normal. And I've already said what normal force I care about. That's why I had to solve for this over here. Now I need to know the mu value. And let's just say that the mu value for the road is about 0.8. So if I want to solve for the force of friction, I need to use that 0.8, has no units, remember, times this 2,842. And so that's going to give me an answer of 2,273.6 newtons. And that's what the force of friction is going to be. So that's what this value of the force of friction is going to be. So that's how you're going to go about all these problems. You always have to solve for the normal force that is linked to the force of friction. The normal force that is linked to the force of friction is always perpendicular to it. So if the force of friction is in the x-plane, like this was, the normal force that's linked to it has to be in the y-plane. So that's the biggest mistake students will make. So it'll be multiple normal forces, and they'll just kind of grab one. It's an easy way for a teacher to really check a student's understanding is to have multiple normal forces. So, but like I said, this is a very simple, straightforward problem, so we don't need to worry about that. So normal force, force of friction, I use my equation for the force of friction that we derived in class, and substitute in your mu value, substitute in the correct normal force, you can find the force of friction. All right, so force friction basics, start here. Come back next time where we see what the Red Hood gets himself into on inclined planes and friction. Ooh, exciting. Until next time, friends, have fun with physics.